Hello everyone, thank you for joining us today. My name is Michael Merriam from CGschool. Today we'll be going over an introduction to PFTrack. This webinar is a preview of what you could learn at the CGschool. Also, the early bird deadline for the first few classes is next week, and this will be your last opportunity to receive up to $300 off each class. And for more information, please check out our schedule at CGschool.com. Seems like we have a couple of people late starting. I know there's been some problems with sound and audio in the previous webinar, so I hope that everyone can hear this clearly and see everything smoothly. I know this video is being recorded right now, so should there be any problems, it will be made available in July. So we're going to be looking at PFTrack over the next hour, and specifically at match moving, of course. It's a technique which is primarily about integrating a CG object into live action footage. We're trying to extract the camera's position, rotation, and any field of view changes that might happen throughout the shot, so that we can have our 3D cameras move in our 3D applications, whether it be Max, Maya, Cinema 4D, XSI, or whatever. So when we render out those programs and then later on in compositing, we can match the original source footage. Now, done well, match moving is kind of an invisible art, and you shouldn't notice it. Done badly, and you will notice it for sure. Things will pop off the screen, wobble, slide, and it's all of those things that we want to try and avoid with decent quality match moving. So we're going to be looking at PFTrack, the Pixel Farms PFTrack. You are able to download a trial version of PFTrack by registering or submitting a request to the Pixel Farm at pixelfarm.co.uk. The only limitation of that would be that you won't be able to export to your host 3D application or your compositor. But everything else that we'll be going through today you will be able to do for sure. So let's just get out of here and run PFTrack. Okay, so we have, let me just check, we have about 108 people on, a fairly large number of people with me having no idea about the user experience of match moving or PFTrack or any other tracking software for that matter. So I'm going to try and move fairly quickly through the next hour without getting too hung up on the small details, but also going to give you a basic overview of the most commonly used functions and tools within PFTrack. It wouldn't make sense for me to spend a long time going over what each individual button does. So what I'll try to do is give you a brief overview, and as I keep revisiting the same tools, I'll explain what I'm doing along the way, and hopefully that'll sink in. So the interface with PFTrack, first of all, it's fairly simple, nice UI to work with. Across the top is the main toolbar for commonly used functions and controls, all grayed out currently because we have no project set up. The main area here in the center, the large open space in the center of the UI, is where we're going to be looking at our source footage, so playing backwards and forwards, and also any other viewers that we might have, perspective or orthographic. Top right is the controls for those particular viewers, which we'll visit those a bit later on. Down at the bottom is where our timeline is going to be displayed with options for playback and also the dope sheet and F-curves for the camera. On the left-hand side, in the project overview, this is where we will have our shots located. We can have multiple shots within the one PFTrack file, and as we would select any of those shots, the shot information per shot is going to appear in this dialog box over here. So the first thing that I'm going to do as a 3ds Max user is to go to File, Preferences, and over in the Calibration tab I'm just going to make sure that UZ is up. If you're a Maya user, that may not be as important for you, but for 3ds Max and to keep things consistent, I'm going to use the Z as up and OK that. Okay, so first of all let's start up a new project. I'm going to click on File, New Project. I'm going to call this test_01, and it's going into the desktop tracking folder, which is just fine. I have one that already exists, and now I'm going to overwrite that. Okay, So now we've got a new project, we can see that it's included an untitled shot, and with that selected we now have the shot overview down on the left hand side through here. We need to obviously import some footage to work with, so with the untitled shot selected, I'm going to go to the import footage icon and then navigate to a piece of source footage supplied by Uniform from a film they did a few years ago for Crystal. And I'm going to select that, 0 to 100 is fine, and load. Okay, so we have 100 frames of our footage. Before I move on to anything else, I'm just going to make sure that we're going to be working at the same frame rate as what we'll be producing our final rendered image or final movie at. So over in the shot overview, I'm going to right click on aerial footage, choose edit format, and in the format drop down choose PAL, which is going to be frame at 25 frames a second. Now it's a fairly long shot for the purpose of this tutorial, but so we don't want to track all of it. It's going to take too long to track forwards, track backwards. So I'm going to just go to frame 50, and at the bottom in the viewer controls, I'm going to just set the out point by clicking on the set out point option here. And that's going to bracket from 0 to 50. I'm going to just cache that as well, so you can watch it play back and get an idea of the camera movement through the space. Okay, it's a fairly simple aerial, an aerial move. It shouldn't really provide anything too tricky for us to deal with. But it's going to give us plenty to kind of go off and get you a good understanding or a base introduction to match moving in general. So, what are we going to be going through? Well, traditionally there's kind of like two main methods of tracking in PF-Track, and that would be first of all doing a 2D track. And from those 2D points, the 3D camera is solved. And then the second thing that we're going to be looking at today actually is geometry tracking to solve the camera position, which would involve no 2D tracking whatsoever. So first of all, we're going to look at the more traditional method, which is very similar to tracking methods from Buju, SynthEyes, and RealViz MatchMover. But before I do that, we're going to have a look at inputting some initial data for this shot. Now, I know what camera this was taken on, and if it's really important, I think, when you're going to be doing any sort of match moving, whether it be for moving images or even still images for architectural work, that you have, or if you're able to, get as much information on the camera as possible, and any information that's within your scene is going to obviously help with the accuracy of the camera match. This was shot on a Sony F900, I think. Well, I mean, I know. Let me just bring up the internet. So this is a camera it was shot on. Just doing a little bit of research, and we can see that it's a 2/3 inch chip, and then scouting around a little bit further than that and finding the Panavision common frames and formats, we can see that their 2/3 inch chip has in inches is 0.3775 across. Now this is a fairly important point to note. Lots of the people get confused sometimes with what the film back is and the CCD and trying to find that information, and it is relatively important that you input that data because it has a bearing on the field of view if you're giving a certain focal length, because with a smaller CCD or a smaller film back or the piece of film as you were, if that's smaller than a 35mm camera, the field of view is going to be different for any given lens. It's called the crop factor, and it's an important point to note with any camera matching. So we're going to input that information from the Panavision website directly into PF-Track. I'm going to do that by going to Camera Parameters, and you can see that it's got a camera preset of 1080 at 24p. Well, we've already set it to PAL, so I'm going to change that to custom. The frame size I've actually reduced for the purposes of quicker playback at 1280 by 720. And a little bit further down, we have the film back. Now, if we switch that to inches and then input 2/3 inch chip, so 0.3775. 0.3, and that will automatically update the height. I can just switch that back to millimeters, so 0.95885. One thing I just briefly skipped over was that when you open up the camera parameters, you're enabled to set some initial states for what kind of shot you're going to be working on. This is obviously a single camera; it's not stereo. It's not stereoscopic. The camera motion in this case is free motion, but you can have options for, say, rotation only, which would be for something like on a tripod where you're just panning through a shot. But I'm just going to leave this on free motion. Going down to the focal length, having watched the shot play backwards and forwards, it doesn't seem like the focal length changes, so I'm going to leave that at constant. And I don't know the lens which was used to shoot this. I'm pretty sure it was shot on a fairly long zoom lens, and it could be anywhere within the range of that zoom lens. So I'm going to leave that as unknown and let the software take care of that when it comes to the camera solve. So now we have the film back. I'm going to close that up. Okay. Let's get on with some tracking. Now, when you load a shot, the options and the tool options become available at the top. There is actually one over here called Track and Solve, and this could be considered a magic bullet in that you could open up your source piece of footage, press Track and Solve, and the software will attempt to, first of all, 2D track your scene and immediately solve for the camera. I tend never to do that because I like to input as much information as I can and don't really like to leave too much up to the automatic way of doing it. One thing I am going to do though is choose to auto track, and this is going to be the first stage in a two-stage process of tracking or matching our camera. So let's go back to frame 0 and choose auto track. What PF Track is going to do now is look for areas within the shot that it can match these 2D tracking points through and then try and track those throughout the duration of the shot. First of all, the solve is going to go forward through the scene, and it's going to improve the solution by retracking those backwards. I think that the audio may be suffering slightly, but that could be due to the fact we're doing some processing on the with the auto track. So if you're having issues hearing me right now, just bear with me. We'll get through this process and we'll carry on. Rest assured though that it will speed up once it gets halfway through because it's already done the majority of the hard work in the first forward pass. Okay, so that's completed and it wasn't too painful to have that track those 50 frames forward and backwards. Now if I just move to the toolbar again, and currently we're in navigation mode, so just by using the left or right mouse I can pan around and then middle mouse to zoom in and out. If I move across to the little pick whip selection, I'm just going to drag a pick whip around the whole frame and choose and select all of our current 2D feature tracks. If I zoom in a touch, you can get an idea of how the camera is actually moving through that scene, with points which are far away seem to move very little, while points in the foreground seem to move more. And it's this parallax that it's going to help PFTrack resolve the 3D camera. Now, we could go through and just click on Solve, but there may be tracks within this shot now that appear to be tracking correctly through the scene, but may be tracking to moving objects or at the intersection between near and far objects. And in both cases, that would actually give us or give the tracker a false indication of where that point is supposed to be in 3D space. So after doing any sort of automatic feature track, it's very important that we survey how these points are moving and then either delete or remove from the solver any points which seem to be doing anything strange. So I'm just going to leave this ping-ponging by going down to the ping-pong option down here, and leave that playing forwards and backwards, and just taking a look at these feature tracks to make sure nothing untoward is happening. Okay, so I spotted one issue. This chap down here seems to slide off left as the foreground building starts to come into shot and seems to push it off. The track looks fairly good, but to the tracker, this moving point would give us a less accurate solve. So I'm just going to pause there, make sure we have the selection picked, drag a whip around that guy and delete him. I'm just going to continue playing. Quite luckily in this case there is actually one of the tracks is tracked onto a van, but it doesn't appear like that van's moving. Previously it had tracked to this guy up here. So in a situation where the trackers are tracking good but to a moving object, they again need to be removed from the solver. This can be a fairly time-intensive process if you have hundreds and hundreds of user features. So in a situation like this, where there doesn't seem to be many situations where things could track to incorrect places or like moving objects as such, it's not so much of a pain. But there are ways in PFTrack to basically mask out areas and to avoid the tracker tracking those regions at all. So if we choose on our toolbar masks, and we want to draw around an area to prevent any user features or auto features being placed in that area, we can do that. So with mask selected, I'm just going to mask out this foreground building by left clicking and dragging. And if I click and drag, I'll be able to create a Bezier handle. Right click to finish the operation. Now the masks have like an auto animate on by default, so I can move through the shot. And holding shift and left mouse button, I can bring up a transform box and just place that back over our building, move through the shot and do the same again. Now, as well as the overall transform, we're able to animate edges, by clicking on edges, or the vertexes too, of our mask shape. Now, without having to go through that painful process of tracking or retracking all of these 2D user features, because there wasn't really time in this demonstration, I may have actually decided to do all of the masking first for those moving objects or areas where I didn't want the auto features to be placed. But for the purpose of demonstration, this is just how it's kind of falling into place. As well as manually animating these masks, there's something else we can do as well. I'm going to draw a second mask just by clicking the root of the mask rather than having our mask selected. I'm going to draw another one over this building in the foreground. Now this is a fairly simple camera move, but if we wanted to avoid to do any sort of manual animation with this, we could link the mask to one of the user features or one of the auto features within our scene to help with the animation of that mask. So I'm going to go to the selection mode. I'm going to right click on one of our auto features and convert it to a user feature. With that done, I can move over into our masks, which is mask 2, right click, and attach that to the user feature. That will now mask off that building. So if there's any areas within our scene that we don't want to have affected by or 2D tracked at all, we can use a mask to do that. That would save us obviously having to delete individually points that seem to be tracking oddly at those places where they might be. Being that this is a fairly straightforward track, I'm going to delete those masks. I'm also going to delete that guy. Okay. Next thing to do for us is to solve the camera. So we've removed a few points. Everything else seems to be working and looking okay. I'm going to move over to the next icon over here, which is Solve Camera. I'm going to leave things fairly default for this particular demonstration. Motion group, camera, keyframe mode, automatic, and just start. So in this process, the 2D tracks are going to be resolved in 3D, and hopefully there'll be a point cloud generated and a camera too. Okay, so you can see now that the interface has changed somewhat. The once crosshairs have now turned into little green dots, meaning that this camera has been solved. And also we've thrown in a grid here with an axis. And if I play through, you can see that we kind of move along this grid. If we go to one of our viewers at the top here, if we just click on New Viewer, we can see the point cloud in 3D space. Now to orientate and navigate this 3D space, it's the same as the navigating a 2D space. We go to the navigation icon and then use left mouse to tumble around, right mouse to pan, and middle mouse to zoom in. Now I can just about see our camera. And the actual camera translation through the scene looks to be good. Nice and smooth. I'm just going to Control Tab back to our previous view. What we need to do now really is we have a 3D solve, but orientation of our scene really doesn't bear any resemblance to what we're actually looking at in the footage. So one thing many people find kind of confusing is orientating that scene and trying to set it up properly. So I'll try and go through how I do this with using this method of tracking. With the feature method. We're going to come over across the toolbar again. I'm just going to hover over scene orientation. So with the scene orientation, it kind of acts a bit like navigation in that when we tumble around the viewport, the grid seems to be moving, or the camera seems to be flying around. Well, the camera's kind of not. We're orientating the scene to the camera and the points. Right, so as I was saying, was that we need to orientate our scene. So when we are in scene orientation mode and are panning around, we're not moving the camera as such, we're moving the scene in relation to the camera. So what we need to do is to correctly align this with the background plate. Now we've got a big horizon line going across the top here, which is going to be a great help when trying to orientate our scene. So if we go to View and then choose Horizon Line, we can see a horizon line which we can try and position into place. What I like to do also is to constrain the way the scene has been orientated by using the Z, X and Y keyboard buttons. So if I was to hold Z down and then orbit using left mouse, it constrains the rotation only to the Z-axis. I just want to finesse this line somewhat, so I'm going to use Y and perhaps a touch of X. Okay, so it looks like for the most part our scene is aligned correctly, but it's also very important, we want to make things and the transition to maps as easy as possible. We want to know where all this is going to be brought in and where is going to be the 000 point within your 3D software. So PFTrack uses the center of the axis tripod here as 000 in the PFTrack environment, and it's this that will translate into your 3D app as 000 also. So we can set that to anywhere we like really by using the right mouse and then either constraining it using the ZX and Y, so I'm moving that up and down, forwards and backwards, and oops, and then along the X-axis, so holding X down and then using right mouse. What I tend to do really though is to pick a fairly obvious point as close to the ground as possible, and then right click on a point. Now it's very difficult to see the ground because lots of the buildings occlude the roads, and so we won't be, we're going to get close but we won't get exactly right on. I'm going to right click and then choose set as origin, and that's going to move our entire world and set the point there as 0000. So if I play that back through the scene now, I've started to get a good idea of how this is being set up. Okay, the next step in this process is scaling our scene. If I just go back to the navigation mode, quickly dip into perspective and zoom out, you can see there's a small ruler here showing you that the grid size is 1 meter for the large grids. Now, switching back to this view, that's obviously the incorrect scene scale for this particular shot. I kind of like to work in meters, so the way that I'm going to scale this is I'm going to go to the selection and then drag a selection marquee around 2 points that I know the scale of. Now, this is going to be fairly arbitrary in this particular shot, but if you're tracking something like house with windows on it or something that you know the exact sizes for, you could perhaps give PFTrack the information between the 2 corners of the window frame, for example, and give it an exact dimension. I'm just going to guess for this though that the distance between these 2 points is about 25 meters. So with those two selected, I'm going to camera, scale scene, and choose 25. And to make sure that actually happens, I'm going to click in the meters option, and then you'll see that the whole scene has scaled down now. So I'm going to OK that. Okay. So we have a scene scaled and orientated. The next step is going to be getting that into 3ds Max. Well, but actually before I do that, let's just have a look at some of the features of the F-curves. Now, being such a simple track, if we go into the camera groups and choose on translation, you'll see that we have a fairly nice graph plotted of our camera translation through the scene. Now, had this been a more difficult track with lots of shake and bump, this line may look a lot more erratic, and we can use some of the features in here to smooth out any serious bumps or errors. That's something that we'd perhaps look at in a more in-depth training day. But right here, right now, in this particular aerial shot, it's a nice smooth curve that we won't need to do anything with. That being said, let's get this straight into 3ds Max and then see how that translation works. At the bottom of the shot information, there is 2 different exporting options. We want to export a 3D camera track, so I'm going to right click on 3D camera on object exports, choose new, and the format's going to be 3ds Max, which is fine. Features all, so that's going to bring in all of the point cloud here. Scale 1, yeah, that's fine, and it's going to export the camera motion group, which is also just fine. Nicely for us, it's going to export the Max scripts into our project folder when we click save. So I'm going to switch over to Max. So before I do anything else, remember that we have set up PFTrack to work in PAL, and we need to make sure that 3ds Max is also using PAL. So in the time configuration, I'm going to make sure it's not using 30 FPS and that it's using PAL. Just double click on that to make sure that the FPS is set to 25. And we know that we also set PFTrack up in meters as well, so I'm going to go to Customize Unit Setup, and display units is millimeters, which is okay, but the system unit scale is in meters. Good. So let's max script, run the scripts, and navigate to tracking. Seems like we're having our issues today, doesn't it? Okay, well thanks for bearing with me. I'm bearing with this too. So let's try and move through, see if we can't get going again. So I don't know how far back the audio dropped out previously, but where I think we left off was I had just navigated from PFTrack after choosing an export for our 3D scene and was just about to run that script inside of 3ds Max. So test 1, aerial footage exports, aerial footage max script. Okay, let's see how we get on. I'm just going to execute that script. Okay, and what that's done is replicated our scene from PFTrack inside of 3ds Max. Hopefully you're all familiar with Max or other 3D software. So all of the helper points here are, of course, the user features, or sorry, the auto features from PFTrack. One of the things I like to do straight away with a Max camera inside that's been imported from PFTrack is to go to the modify options and actually turn off clipping planes, because the PFTrack camera comes in with clips manually, so I'm going to turn that off. If we go to up here, we can see the lens is 6.77mm. Let's just have a look at what the camera solved the lens at inside PFTrack by going to camera parameters. 6.77037. Okay, with a film back of 95885. Well, we need to make sure that this is set to 95885 Well, if there is anybody still here, you've got more patience than I've got left. Again, I'm going to try and kick off from where we just stopped a moment ago, and that was we just imported we just run the script from PFTrack inside of Max. We've checked to make sure that the lens and the field of view both match the camera parameters from PFTrack, and also that we've also put the film back at 9.5885 and made sure that the aperture width in the render dialog within 3ds Max is set to 9.585. Okay. Now, if I just navigate and add the environment background, just to double check that our point cloud is lining up with our background source footage. it does appear that everything seems to be in the right place, which is a huge relief. So that's the kind of more traditional method of camera matching using user features, auto features with an auto track, doing a little bit of cleanup for those tracks, and then solving the 3D camera. And then we've had a look at orientating our scene very briefly and scaling that too. What I want to move on to, and what I find really exciting about PFTrack, is geometry tracking. Now, geometry tracking can be used for doing head replacements, tracking moving objects through scenes with moving cameras. But I found that with, especially with architectural work, that you can also match cameras very accurately from 3D data that you might have about a particular area. So I'm just going to open up London basic geometry model. Okay, so what we have here is a medium resolution model of some of the buildings which are visible in our source footage. Now these, for geometry tracking, they don't need to be terribly accurate. In fact, you can get away with block models, say, extruded from site or CAD information. If you're lucky enough to have photogrammetry, if you're doing something on a slightly smaller scale, or even LiDAR, then you can use that information to build up a block model, which can aid you in your tracking process. So just to explore this scene slightly, let's make sure that it's set to PAL. Just make sure that the units are as we expect, so display millimeters, system units in meters. And what I'm going to do is take this 3D model and prepare it for an import into PFTrack. So File, Export, Selected. I'm just going to dump it in the root. Let's call it O2. Okay, so we just exported a model out of Max, and we now need to duplicate our shot and look at the second method of tracking, which I want to show you in what's left of today's demo. I'm going to right-click on our our aerial footage here and duplicate. I'm just going to duplicate that with geometry. I want to remove all of the data that we've got here, including the 3D camera move. So I'm going to go to Tracking, Clear Auto Features, which will ask me if I want to discard all the objects and discard all of the camera and object motions too. So yes, and that's just going to take us right back down to just the source footage playing within our scene. It won't have affected the camera parameters as such, so the film back is still 9.5885 as we had put it initially. So that's good. So what we want to do this time is take a slightly different approach, and there's going to be no 2D tracking involved in this process. So I'm going to go to File, Import Tracking Geometry, Desktop, Tracking, London Basic GO2, and open that up. Okay, so what you'll see in the shot overview on the left hand side is we have our tracking geometry, and below that now the imported object file. Now what's also happened in the main viewer is we have an extra set of controls down the bottom here. Fly camera is about how we actually orientate the scene, or how we orientate our camera in relation to this 3D model. Hidden line is just about really how it's displayed in the viewport, so we can go to smooth, for instance, or wireframe. But I like working with hidden line. And then we have some options for painting weights, locking, translation, rotation, field of view, and then the track forward and track backwards tools icons down here too. So the first thing we need to do is to roughly position this 3D model to match our background plate. So again, I'm just going to use the middle mouse in the navigation mode using fly camera to orientate our scene. Now, if I spin this round, in the footage the gherkin is behind Tower 42. In our 3D model, the gherkin is behind Tower 42, but it's behind the well, what we're going to say, the gherkin is behind Tower 42, but on the flip side. So PF track works on a left-handed coordinate system. We need to make that work on a right-handed coordinate system. So if we go to the shot overview, right-click and choose right-handed, that will flip our model which means that we will be able to fly this into position much more easily. So roughly get it into position. And that's about as far as we're going to get it using the fly camera method. So I'm going to switch from fly camera to pin. Now, using the left mouse is no longer going to orientate our camera in relation to our 3D scene. What we are going to have to do now is pin our 3D model to our background plate. So I'm going to hover over a vertex and you'll see we'll get this red icon. So the first time we pick up a pin, it's going to move the entire model. Oh, it's going to move the camera in relation to the model. And I'm going to place that over the background. The second time we place a pin, it's going to constrain the movement to the position of the first pin. Now, as we go through the model and try and pin more of it to the background, we're going to start finding it harder to do because we haven't allowed the field of view to change as we're positioning our camera in relation to this model. That's because the F button down here is unchecked right now, so we're not allowing the focal length to change as we do this. So it's important that we make sure that F is checked also, so we allow field of view changes when we're orientating our 3D model. Let me just pick this chap up. It looks like they're having audio problems again, so I'm just going to see if I can wait this one out. Okay, it seems to be bearing with me. I tend to do a few of the background places first and then zoom in and try and nail down a few of the foreground objects as two. So let's take okay. So that's looking good, and what's nice about this is that the horizon line that we left on from the previous 2D track, just by positioning our 3D model, has come in the right place, and it's kind of confirming that our basic overlay of 3D geometry is in the right place. So that's right now that's a good thing. You can see that I've started to place a geometry in at frame 45, and therefore it's keyframed it from this position. So with that done, next thing to do is track the geometry forward and backwards through the scene from this initial keyframe here. I am just going to, with that geometry object selected, I'm going to track forwards. It's relatively painless, and then track backwards from that keyframe. This process is actually usually fairly quick, but seems to be relatively slow right now, due to, I think, doing the screen capture as well. But the difference here is that compared to the previous method of doing 2D tracks and then relying on the camera solve to happen after that's completed, this is just using the geometry and then working with the geometry to create the camera solve essentially on the fly. Okay, with that done, we should be able to play through the sequence now. So the steps involved in doing a 3D geometry track for extrapolating the camera motion are far less involved, really, than the 2D method. There's no scene orientation required after the camera solve is done because it all took place when we initially placed the 3D model. So that looks good. We'll just check that in the perspective viewport. And of course, scene scale has been taken care of too, because the geometry comes in already scaled. So again, the camera motion looks nice and smooth throughout the shot. Okay, so happy with the camera motion. The geometry looks good. It's tracked through the scene. It's now a case of getting that back into 3ds Max and then making sure that aligns up with the original 3D model. I'm going to go right-click, choose a new export. Area footage GO2 will do fine. Max script, yes. Features all. There isn't any feature tracks, but we'll leave that on all. Tracking geometry, yes. We'll bring the tracking geometry back in too. So I'll click save. Switch to PF track. Sorry, not PF track. 3ds Max. And then Max script, run scripts. So there's a new Max script here, footage GO2. We'll go with that. Okay, the script is run. It's automatically put us back into the camera view. Same thing I'm going to do as before, is make sure clipping planes are turned off. You can see that the lens over here says 36 millimeters. Now, I'm pretty sure that it won't be that in here. It's going to be 9.644, very close to what the other tracking had given us. So the difference, what's the field of view? 52.9, 52.865. Well, we need to make sure that the aperture width matches that we put into PF track. So let's put the film back at 95885. 9.55. Okay, and that has, the field of views remain the same, but the lens has come down to what we'd expect and now matches PF track. So the re-imported model is coming into the correct places. There's no room for error really bringing it back into Max, and nothing is arbitrary. We didn't have to set a 000 point in PF track and rely completely on the fact that tracking geometry it was already located in the correct place. That's one of the main reasons that I enjoy using the geometry tracking, is that it takes less time to orientate things to your imported scene within a 3D application. that's where I'm going to leave PF Track for today. I know we've had our problems with audio and the video dropping out. I did record all of that, even the breaks, so all of this can be put together and hopefully re-watched without any of the interruptions that we've had so far. I can take a few questions for a few minutes if anyone does have any, to kind of make up for the problems that we've had. So by all means, fire away in the chat area, and I'll see if I can help you out if you do have any questions, of course. But apart from that, thanks very much. I've been asked, what's my CPU power? Okay. Let me have a look through some of these questions. Yes, I'm back. Yes, to answer some of the questions, yes, I have recorded all of this. What is PF Track for, someone's asking? Well, it's for match moving. I did explain that at the beginning. It's for matching and integrating CG objects into live action footage. How much is the scene in megabytes? Not very big. My ringtone's quite nice. Yes, I'll put it on silent next time. What kind of CPU power am I using? It's actually running off a Sony Vaio laptop, so really it's kind of worked very well. Weight of this file in megabytes. Again, people asking that. Let me have a look. The project file is 1K. The exported Mac scripts, wherever they are. The aerial footage, Geo 2, the last one we did with the geometry tracking, was just over a meg. Not very big at all. How long has it taken to learn the program? I've been using PF Track quite a while. I've been match moving previous to that with RealViz Match Mover. My CPU config and stats. Why not After Effects? Because After Effects can't do 3D tracking, it can do 2D tracking. This is extrapolating a 3D camera from 2D footage. After Effects can't do that. So yeah, you can track in 2D plates in After Effects or Fusion or Nuke. I believe that there is some 3D tracking applications or plugins for Nuke coming out soon. I'm not 100%, but so I shan't say too much. What about Boujou? I did mention Boujou at the beginning of the demo. There's a number of different trackers out there. I like PF Track mainly because of the tracking geometry, but there's 2D3's Boujou, which is a very good product. Anderson Technology Synthesize, which again is very good. What else is there? There's 3D Equalizer. There's another one. Let me have a look. Why wasn't I wasn't here from the beginning? So just one quick question: is there a way to find out camera information and lenses? Well, ideally, you would try and record the focal length of the lens you would use. You might have a script supervisor on set that could take that. But the really important thing to get when tracking is to try and find out the CCD or the film back or the image size of the light sensitive portion of the camera, because that will have an effect on the field of view when used with a 35mm camera. Have a look for crop factor on Wikipedia or something like that, because it's a hugely important element of any camera matching, both for stills and motion tracking. Where to find information about this stuff? I tend to go to the Panavision website. Oh, it doesn't look like I can paste that in here for some reason, but yeah, check out the Panavision website, and there's some references in there for different frame formats and width and height of the CCDs and sensor sizes, which is very useful. I asked a question before because I want to let's have a look. How long does it take to execute such a project like this, both Max and PF Track? Well, if this had gone super smoothly, the tracking process doesn't take very long usually. So like something like geometry tracking, even on Sony Vaio laptop, was relatively straightforward, got a good result, and importing that into Max was almost seamlessly smooth, but we've had our issues obviously today. Who to calculate focal length manually in PF Track? If you're asking if you already know the focal length, you can go to camera parameters, and currently mine was set to unknown because it was such a long zoom lens. I had no idea whereabouts the focal range was, whereabouts the focal length was. So if you do know it, you can change that to known and then type in exactly the focal length that you know the lens or the shot was taken with. But if you're going to do that, you absolutely must put in the correct film back. Can it be used to track objects in motion while camera is static? Yes, absolutely. You can even do moving camera and moving object for, like, I don't know, head replacement whilst the camera is panning down a street, for instance. I'm going to take maybe 3 or 4 minutes more questions, and I'm going to have to call it a day and stop recording. Yeah, I just wish, well, thanks for that. Everyone's saying it was, loved it, and that's good. I'm just really sorry that the audio dropped out so many times. It's a shame. It's faster than the original Max 3ds tracking, right? Well, damn right, and it does a lot more too. The algorithms within PF Track and the geometry tracking, it's not even worth thinking about the original one in Max. Okay, 2 more minutes and I'm going to wrap it up. There are tutorials online by different vendors, and also I think some things other people have done too. In the 3D ATS Advanced to Expert book, I also wrote a chapter on specifically this subject with this tutorial in too, so that's step by step in that book. And if we don't know the focal length, what can we do? How about testing your track? Well, thanks Andy for that question. Yes, it should be tested, but within the hour that we had, we couldn't have done it. Can you single track a frame as if you want to insert a 3D single picture? Yes, you can do that. If you don't know your focal length, then what can you do? Well, in a lot of cases, you don't know your focal length, and that's where you're going to rely on. If you're importing tracking geometry, well, as I've done in that last section, and you uncheck the. If I just select it again in the viewport. If you're bringing in tracking geometry, you uncheck field of view, and your model is accurate, then with the field of view unchecked, you're forcing the forcing the field of view, which will give you a focal length. As far as tracking markers, which colour would be ideal for green screen shoots? Tracking markers are tracking markers. You're going to have to, if they start crossing behind people, you're going to have to remove them manually. You can export 2D tracks from PF Track into your compositing applications, which will help in the rotoscoping of removing tracking markers, but in a green screen studio, shoot red, but you're going to have to do some manual rotoscoping at some point. How would you, Andy's asking, how would you test your track in PF Track? I tend not to, because I don't really use the test objects in PF Track, in that I don't render out PF Track to make my movies in the end. So I'll bring it into Max and I'll render out TPAT on a plane with shadows to make sure that the shadows, when you're rendering out without shadows as a test, stuff looks like it might be grounded, but when you render out of your 3D application with shadows as a test, just do something quick, don't have to have GI or anything stupid like that. If those shadows seem to be sliding around, you can guarantee that you've either got the scenery orientation incorrect or the tracking's off slightly. So just doing a test object, it might look good, but it might not be grounded where you would expect it. Is it either to the, is it easier to learn than 3ds Max? Yes, there's far less steps involved in learning PF Track. I pretty much think that anybody could pick up tracking. It is a means to an end, and again, done well, it should be an invisible art. Alright, can you please explain quickly how to blend multiple camera solves? That's a good question. No, I can't quickly explain how to do that. I was going to wrap it up a minute ago, so yes, we can do that over an extended period of training, but not now. Okay, well, just to reassure everyone, that was entirely recorded. Even through the breaks, I stopped it and restarted it. So I'll wrap it up there, stop the recording, and that will be made available at some point through July, including my phone ringing also. All right, thanks for that.